Hi, this is Leetcode question. Reorder routes to make all paths lead to the city 0. In this example, the answer is 3, and that's because we have to change the direction of 3 connections. After doing that, all the cities can reach the capital city 0. Now, how can we solve this question? In order to make all the cities reach the root node 0, what we need to do to count or to flip all the connections that point downwards far from root 0 and change the direction to point towards the root 0. So this connection points downward. We need to flip it. So this is the first connection, and this connection point downward, so we need to flip it. This is second connection, and this connection here point also downward. We need to flip it. So this is the third connection. This connection here we need to flip it. So this is the connection number 4. So in total we have 4 connections that we need to change their directions, and after that all the cities can reach node 0. For example, 7 can go to 5, then 6, then 0, and 4 can go to 2, then to 0. Now, how can we get this answer? What we will do is doing DFS from the root node into all the nodes, and to do that we need to create the adjacent list G, in which we store for every node all the neighbors. So for example, 0 contains neighbor 1, 2, 6. 1 contains the neighbor 0 and 3. And we have connection root that maps each connection to the root. For example, node 1, 0, this is connection 1, 0. In this case, we'll store that this connection, here we have min and max, just to refer to this connection. So 0, 1 as a key, and for this connection the root of this connection is 1. For 1, 3, the root is 1. For 0, 2, the root is 0. For 4, 2, for 2 we store 2, 4, so min first, max first, 2, 4 as a key, and the root of these two is 4, and so on. We do this for all connections so that we know for every edge what is the root value, and starting from the root node 0, we will visit all the neighbors using DFS functions, and we will store the count. This is the number of the connections that need to be flipped, and this is the current node, this is the parent. First call, we start with node 0. We consider the parent as -1. So we start from node 0, we visit 1. Now 0 is the node, the parent is -1, and we iterate over all the neighbors of g of 0. The neighbors are 1, 2, 6. Start with 1. Now we need to check what is the parent of this edge 0, 1. The parent is 1. Now if the parent is the node, that means we have to increase the count, or we have to flip this connection. In this case 0, 1, the parent is not the node itself, it's the neighbor, so we don't need to increase the count. And we do DFS for 1. Now all the neighbors for 1 is 3, so we have 1, 3, 1, 3. The parent is 1. In this case it's the node, and that means we have to increase the count by 1, because we have to change the direction for this node. And we do the same for all the edges, and at the end the count will store 4. The parent here is the parent node, so when we visit 1, the parent is 0. All the edges or all the neighbors for the node 1 are 0 and 3. So because parent is 0, we don't want to visit the parent again. We need to go down in the tree, the same as here. Visit 0, then 6, then 5. When we are at 5, we don't want to visit 6. We need to visit 7 and 8.